Let's continue our lecture video in integral calculus with the topic integration techniques using integration by parts. Now, there are equation wherein you cannot integrate it by simply using the power formula, the logarithmic, exponential, trigonometric, but we need to employ the use of technique in order to integrate it. And the first one here is the integration by parts. Now here is the formula or the pattern. We have integral of u dv is equal to uv minus integral of v du. And we need to remember that in choosing for the u here, we need to remember liate, wherein L is logarithmic, I is inverse, A is algebraic, T is trigonometric, and E is exponential. So whichever comes first here from this order is the U, or the one we will let as U in the pattern. So let's try to solve these sample problems. Number 1. Integral of y e raised to negative 2y dy. If we will be trying to use here exponential, let's say u is equal to negative 2y, therefore du is equal to negative 2 dy. So if we follow the pattern for exponential, y will be missing. So we will not be using exponential function in solving for this. So we will incorporate the technique of by parts. So again, in liate, so using the pattern here, which will we assign as u? So we have logarithmic, there's no logarithmic in this original equation. We have inverse, there's no inverse. Do we have algebraic? Yes, we have algebraic, which is y. So it comes before the e, the exponential. That's why in this example, we will put u as the algebraic y. So let u is equal to y. So again, having accomplished the value for u, so here is the u here. So how about dv? For dv, so we will have here a line. So integral of dv, just to complete this pattern, integral of u dv. So for dv, we will put here the one left, which is e, integral of e raised to negative 2y dy. So here, if we integrate this, we have u is equal to negative 2y du is equal to negative 2 dy. So this is equal to integral of e raised to negative 2y. The du is negative 2 dy. Then to compensate, we need to put 1/2 outside. So for the solving of exponential function, watch the previous videos. Okay, then another line. Then from here, from the left part, we have u is equal to y. We will need the derivative of u. So we were able to accomplish this pattern, the u and the integral of dv. Now we need to find the value for du. So for the du, we have here derivative of y is dy. So check. So we have dv, we have u, we have du. How about the v? So we need to find for v. To find v, we will be integrating the right portion. Okay? So the integral of e raised to negative 2y is v is equal to negative 1/2 e raised to negative 2y plus c. So that is the what we need. Then let's have the pattern. For the answer, we have here uv. So u multiplied with v. So we have here an arrow, u to b. So that is equal to negative 1/2 y e raised to negative 2y. So next is minus the integral of v du. That is integral of v du. Let's put here a parenthesis. The v multiplied with du. So our v is negative 1/2 e raised to negative 2y multiplied with dy. We will be removing plus c because of the presence of the integral sign. Okay? And then we will now solve for the, or let's simplify this first. This is negative 1/2 ye raised to negative 2y. This is positive 1/2 integral of e raised to negative 2y dy. So we can now integrate this part here using exponential function. So we now have u is equal to negative 2y, du is equal to negative 2 dy. So that's equal to negative 1/2 ye raised to negative 2y plus 1/2 integral of e raised to negative 2y. We have here negative 2 dy. Then to compensate, we will put here negative 1/2. Therefore, we have here negative 1/2 ye raised to negative 2y minus 1/4 of e raised to negative 2y plus c. So we can have this as the answer. Or we can have it as equal to negative 1/2 e raised to negative 2y multiplied with y plus 1/2 plus c. So that's the pattern for by parts, integration by parts. So that's for number 1. Let's go to number 2. So we have integral of y ln y dy. If we let u here as ln of y, we have here du is equal to 1/2 or 1 over y dy. So we cannot use here logarithmic function because instead of having y over 1 over y here, what we have in the original equation is y. So for the solving of logarithmic function, refer to the previous videos being uploaded. Okay, so we cannot use the logarithmic function. So if we let here, if we will be using here by parts, then again, let's go back to Liate. So we have here logarithmic, and obviously it comes first. So if logarithmic comes first here, we will have here u is equal to the ln of y. Then, so again the pattern so that we won't forget. So we're looking for the u, then the integral of dv. So integral of dv is equal to the one left, which is integral of y dy. Then, so having u and integral of dv, we will be looking for the du and v. So we have here du is equal to 1 over y dy. And then we have here the v. So the derivative of dv here is y squared over 2 plus c. So using the pattern, we have u multiplied with v, and then the integral of v du. So u multiplied with v, we have here y squared over 2 ln of y minus integral, then parenthesis. We have 1 over y multiplied with y squared over 2 dy. So we have y squared over 2 ln of y. This is minus, so we bring out 1/2 integral of y dy. So this is equal to y squared over 2 ln of y minus 1/2 y squared over 2 plus c. So this is equal to y squared over 2 ln of y minus 1/4 y squared plus c. So this is now the answer. Or we can simplify. We can have here y squared over 2 times ln of y minus 1/2 plus c. So that's for number 2. Next, number 3. So for number 3, we have the integral of u squared sine 2u du. So using here by parts, integration by parts. So from Liate, we don't have logarithmic, we don't have inverse, but we do have algebraic, which is u squared. So algebraic comes before the trigonometric t. So we will let here u is equal to u squared. Then the integral of dv is equal to the one left, integral of sine 2u du, wherein u is equal to 2u, du is equal to 2 du. So it's kind of awkward, so let's put here prime so that you won't mistake it for just obvious. So this is now equal to integral of sine 2u, then we have 2 du here to balance it with 1/2. Okay, so we will be using here trigonometric function. So here we have du is equal to 2u du, then v is equal to 1/2, then the integral of sine 2u is negative cosine 2u plus c. So v is equal to negative 1/2 cosine 2u plus c. Then, using the pattern, again, we have u multiplied with v. So we have there negative 1/2 u squared cosine 2u minus integral of minus the integral of v du. So, v multiplied with du. That is negative 1/2, then 2u, or, okay, so negative 1/2 cosine 2u multiplied with 2u du equal to negative 1/2 u squared cosine 2u plus, so cancel out 2 here. What's left is integral of cosine 2u du. So using trigonometric function again, for this, we have here u is equal to 2u, du is equal to 2 du. So this is, so again, this is by parts. Why? Because I forgot to include u. So it is u cosine 2u du, this part here. Therefore, again, we will use by parts. And we will put u as the algebraic u here. So u is equal to u. Integral of dv is equal to integral of cosine 2u du. So if you notice, we are doing integration by parts twice in this problem. Then we let u is equal to 2u, du is equal to 2 du. So that is equal to integral of cosine 2u 2 du. To compensate, we will put 1/2. So du here is equal to du. Then we have v is equal to 1/2 sine 2u plus c. Integral of cosine 2u is sine 2u. Then from the pattern, we have here uv and then v du. But we need to not forget, so this is what happens when my students are having quiz. Sometimes they forgot to include the previous term. Rather, they often go to this part here. They continue with their pattern and then they forgot this portion, this term. So, it will make the answer incorrect. So, always make sure to include the previous term, which is the negative 1/2 u squared cosine 2u plus the new one that was solved by integration by parts, which is uv, which is 1/2 u sine 2u minus integral parenthesis of v du. So 1/2 sine 2u du. Closed. Then, looking at this part here, we can now incorporate trigonometric function. So we will put here u, or we will simplify first. Negative 1/2 u squared cosine 2u plus 1/2 u sine 2u minus 1/2 integral of sine 2u du. Then we will put u here as 2u, du is equal to 2 du. Then this is negative 1/2 u squared cosine 2u plus 1/2 u sine 2u minus 1/2 sine integral of sine 2u. Then we have here 2 du. To compensate, we will put 1/2 outside. Then we have here negative 1/2 u squared cosine 2u plus 1/2 u sine 2u minus 1/4 of, What is the integral of sine 2u? We have there negative cosine 2u. Then since there's no longer integral sign, plus c. So let's simplify, or just put here negative 1/2 u squared cosine 2u plus 1/2 u sine 2u plus 1/4 cosine 2u plus c. So this is now the answer. Now, my solutions are always detailed in this lecture just for you to see what is happening. But in my experience, when using by parts, I could often skip some of these lines. You just need to remember the things to remember here so that you won't miss out on the final answer. So yes, integration by parts is tedious, but having enough practice, you will solve this a lot faster. Now, how about checking? Because we did twice of the integration, are we sure that we got the correct answer? Well, you can always do the checking. Checking is by deriving the answer. So this answer here, we will be deriving derivative of negative 1/2 u squared cosine 2u. The good thing with knowing that this is the way for checking is that you can immediately know if what you did is right. Okay, so the derivative of this is negative 1/2. So this is derivation by product. So we have here u squared. Derivative of cosine 2u is negative 2 sine 2u. Then we have the other one, negative 1/2 cosine 2u. Derivative of u squared is 2u. Then we have the next, we will be deriving this. So derivative of 1/2 u sine 2u is plus 1/2 u. Derivative of sine 2u is 2 cosine 2u. Then plus 1/2 sine 2u. Derivative of u is 1. Plus the last one. 1/4. Derivative of cosine 2u is negative 2 sine 2u. Plus derivative of c is 0. So this is equal to, cancel negative 2. We have here u squared sine, sine 2u minus, cancel 2. We have cosine 2u or u cosine 2u. That is u cosine 2u plus, we have here u cosine 2u. Then we have here plus 1/2 of sine 2u plus minus 1/2 sine 2u. So final answer is, cancel u cosine 2u with negative, cancel this one here. What's left is u squared sine 2u. And the given is u squared sine 2u. Therefore, we are happy that this answer is correct. So that's all for number 3. Okay, so let's proceed to number 4. Okay, so we need to obviously warn you that this one here has also a long solution and it has two solutions. Two solutions but same answer. So let's show the first solution. And then the reason why I'm showing the first and second solution is that we will need to remove the usual mistake that some of my students have made in the past. So that's why we will have two solutions for this. The first solution is that looking at this, using Liate, they're both trigonometric. So obviously, any one of them will be the u. So if we let u is equal to sine x for the first solution, therefore, our integral of dv here will be integral of sine 4x dx. Let u is equal to 4x, du is equal to 4 dx is equal to integral of sine 4x 4 dx. Compensate with 1/4. Then we have here du, derivative of u is, derivative of sine x is cosine x dx. Then for the integral of dv, we have here 1/4 integral of sine 4x is negative cosine 4x plus c. And this is one of the mistake. You cannot cancel the angle here, the 4, since you were seeing 4, you cannot cancel that because the 4x here is the angle for cosine. So you cannot just cancel it like that. No. So v is equal to negative 1/4 cosine 4x. I saw that happen, canceling this here, just because they're both 4. No. It's wrong. Okay? Using the pattern, we have u times v. So we have negative 1/4 sine x so negative 1/4 sine x and then cosine 4x minus integral parenthesis of v du. Okay, so the pattern v du. So that is negative 1/4 cosine 4x. Here is the one that you need to make sure always, so that you will not get confused or you will not get the wrong answer. Take note that if your answer here is 0, obviously you did it wrong because the answer for this problem is not 0. But I often see that when my students makes mistake in these kinds of problem, their answer is 0. So the one that you need to take note here is, since the given is both sine and the only difference is their angle, x and 4x, whenever you do the solution, always make sure that you put the one with the angle x first if we let u as sine x or the one with the x angle. So in this portion here, what I'm going to do is, instead of putting cosine 4x first, I will put cosine x first, and then followed by the cosine 4x. You will understand the reason why if you try to put cosine 4x first and then you will get confused later on with the integration. So you just need to be consistent with what we put first here. So I put the one with the angle x first. So this is negative 1/4 cosine x cosine 4x dx. So this is equal to negative 1/4 sine x cosine 4x, positive 1/4 integral of cosine x cosine 4x dx. Again, looking at this integration here, it is obviously another by parts. And if we let u, so this is one thing that you need to remember so that your answer won't be wrong. If we let u here as sine x, we will let u here as cosine x, not cosine 4x. I repeat, if we use here sine x as u, we will use the second integration as cosine x. So you will have a hint that in the second solution, the sine 4x here will have a cosine 4x in the second integration. That is the second solution. But for the first solution, consistently, we will have u as the one with the x angle. So I just need to emphasize that always. So integral of dv is equal to integral of cosine 4x dx. Let u is equal to 4x, du is equal to 4 dx. So that is equal to cosine 4x, 4 dx, compensate with 1/4. Then we have here du is equal to negative sine x dx. The derivative of cosine x is negative sine x dx. For the integral of dv, we have there v is equal to 1/4. Integral of cosine 4x is sine 4x plus c. Then, using the pattern, again, don't forget to include the previous term. And this is the thing that, this is another one that is being forgotten, or the one mistake that is done in this problem is that 1/4 or the constant is being forgotten. So if we put here negative 1/4 sine x or sine 4x plus, make sure you put also the constant 1/4, and the one that we have integrated by parts, need put here inside this, and that is, the pattern is u dv, just for the space. So u dv is uv. So u and v is 1/4. And then again, we have cosine x sine 4x minus integral parenthesis integral of v du. So we have here negative 1/4 sine x sine 4x dx. Then let's close this. Okay. So this is negative 1/4 sine x cosine 4x plus, this is 1/16 cosine x sine 4x plus, we distribute here 1/4, so this becomes, then since negative sign here, so this is positive 1/16 integral of sine x sine 4x dx. Okay. Now, do we need to conduct another by parts? That will be the third one, since there's still a an integral sign here, well, you need to notice that this part here, the integral of sine x sine 4x, is actually the original equation, integral of sine x sine 4x. So what do we do with this one? Now, from the original or the given equation, from original equation, we have the given sine x sine 4x dx is equal to, let's copy this, negative 1/4 sine x cosine 4x plus 1/16 cosine x sine 4x plus, we have 1/16 integral of sine x sine 4x dx. So meaning we can now algebraically conduct a 1 minus 1/16 here. So what is 1 minus, if we transpose this to the left side, it will become negative 1/16 integral of sine x sine 4x. So what is 1 minus 1/16? It is equal to 16, 16 minus 1, so that is 15/16. Therefore, we have here 15/16, the integral of sine x sine 4x dx is equal to negative 1/4 sine x cosine 4x plus 1/16 cosine x sine 4x. So, no more integral sign on this left portion. Then, to remove 15/16 here, we need to multiply both sides with 16/15. Multiply this also with 16/15. So, what happens? Okay. So, to use space here, let's arrange this properly like that. Okay. So we will multiply this with 16/15, also 16/15, left and right portion. So cancel this one out. What's left is integral of sine x sine 4x dx. That is equal to 16/15 multiplied with negative 1/4. That is equal to negative 4/15 sine x cosine 4x plus, what is 1/16 multiplied with 16/15? Cancel 1. I cancel 16. We have 1/15 cosine x sine 4x. Since there's no longer an integral sign, this is plus c. Meaning, this is the answer for the integral of sine x sine 4x dx. So this is for number 4, first solution. Okay, screenshot first. Okay, now let's proceed to the second solution. For the second solution, this time, if we let sine x first, this time we will let sine 4x first. Sine x dx. Okay? Then, we will let u here as sine 4x. Or shorter. So what's the integral of dv here? Becomes integral of sine x dx. Then the integral for sine x is, this v is equal to negative cosine x plus c. du here is 4 cosine of 4x dx. So 4 cosine 4x dx. Then from the pattern, we have here u multiplied with v. So we have negative sine. Again, if we have the first one as the one having the angle 4x, then we'll put here sine 4x, negative sine 4x cosine x, minus integral parenthesis of v du. That is 4, or that is negative 4 cosine 4x cosine x dx. So that is equal to negative sine 4x cosine x plus 4 integral of cosine 4x cosine x dx. Then the second integration, we will let u is equal to cosine 4x. So we're using 4x first. So integral of dv is equal to the one left, which is integral of cosine x dx. du here is equal to negative 4 sine 4x dx. v here is positive sine x plus c. Then, going to the pattern again, do not forget this portion, including the constant 4. So we have negative sine 4x cosine x plus 4. Then the answer for this is uv. u multiplied with v. Then I will put here the cosine 4x sine x minus integral parenthesis of v du. That is negative 4 sine 4x sine x dx. Let's close it like that. Then we have here negative sine 4x cosine x plus 4 cosine 4x sine x. Then distribute 4 here, becomes positive 16 integral of sine 4x sine x dx. Again, notice that this here is from the original equation. So, let's insert the original equation. The original equation is integral of sine 4x sine x dx is equal to, let's copy this, negative sine 4x cosine x plus 4 cosine 4x sine x plus 16 integral of sine 4x sine x dx. So this 2 here is now similar. So what is 1 minus 16? We transpose this to the left side, becomes negative 16. So 1 minus 16 becomes negative 15. So we have here negative 15 integral of sine 4x sine x dx is equal to negative sine 4x cosine x plus 4 cosine 4x sine x. Then multiply both sides with negative 1 over 15, just to remove the negative 15 on the left side. Negative 1 over 15. So cancel out. What's left is integral of sine 4x sine x dx. That is equal to, distribute negative 1 over 15. This becomes 1 over 15 sine 4x cosine x minus 4 over 15 cosine 4x sine x plus c. So this is now the answer. Now the question is, did we got it right? Like, did we have a similar answer with the previous one? So this is the second solution. So 1 over 15 sine 4x cosine x. Does the first answer has that? Sine 4x cosine x? Yes. It has 1 over 15 sine 4x cosine x. Although they are interchanged, cosine x and sine 4x, still they're the same. Okay? They're just interchanged like that. But still, the answer is the same. And then, we have here negative 4 over 15 sine x cosine 4x. The second answer, negative 4 over 15, we have the sine x, then we have the cosine 4x. So they are the same. So whether you use solution 1 or solution 2, the same answer will be solved. Now the question is, we did a tedious solution there. It's long. Is it correct? Checking by differentiating d dx 1 over 15 sine 4x cosine x minus 4 over 15 cosine 4x sine x plus c. See, if we'll go back to the given or the original equation. So we have here 1 over 15, so the first one. 1 over 15 sine 4x, derivative of cosine x is negative sine x, plus 1 over 15 cosine x, derivative of sine 4x is 4 cosine 4x. Okay? Next, this portion here, derivative of, so we have here negative 4 over 15 cosine 4x, derivative of sine x is cosine x, minus 4 over 15 sine x, derivative of cosine 4x is 4, so negative actually, it's negative 4 sine 4x plus 0, derivative of c. So we have here equal to negative 1 over 15 sine 4x sine x plus 4 over 15 cosine x cosine 4x. We have negative 4 over 15 cosine 4x cosine x, positive 16 over 15 sine x, sine 4x. Cancel this 1 out. And what's left is this one, these ones. And the answer for that, what is negative 1 over 15 plus 16 over 15? That is 15 over 15, or the final answer is sine 4x sine x. Okay? Therefore, since we were able to derive from the answer the given, therefore, these answers are correct. So, screenshot the second solution before we proceed to the final example, number 5. So, number 5, final example. So, sine of ln x dx from Liate. So, does it mean that we will let u is equal to the ln x? The answer is no. It's not the L. So, which one? What we have here is only trigonometric. Ln x is actually the angle for sine. So, we only have here trigonometric. Therefore, we will obviously let u is equal to sine of ln x. So, we have here integral of dv, the one left, integral of dx. Then, we will have the derivative of u here as, so du is equal to cosine of ln x. Then the derivative for ln x is dx over x. So du is now equal to cosine of ln x all over x dx. How about here? We have here v is equal to x plus c. From the pattern, so we have the pattern again, u multiplied with v. So we have there x sine of ln of x. Then, next pattern is negative integral of v du. Negative integral, parenthesis, v du. So that is x times cosine ln of x all over x dx. Cancel the x. So we have x sine ln of x minus integral of cosine ln of x dx. So again, we will use integration by parts with u here equal to cosine of ln x. Integral of dv is equal to integral of dx. Then du is equal to negative sine ln x. Derivative of ln x is dx over x. So du is negative sine ln of x over x dx, where v here is simply x plus c. Then, we will not forget this portion here. We will rewrite it here. So, x sine ln of x minus the answer for this. So, we have the pattern u times v is equal to x cosine ln x minus the integral parenthesis of negative sine ln of x all over x. Then we have x dx. Cancel again the x here. So let's close it. So we have here x sine ln x minus x cosine of ln x. So this is negative times negative positive multiplied with negative outside. So negative negative positive multiplied with negative, this becomes negative. Negative integral of sine ln x dx. So looking at this integral of sine ln x dx, it's actually the given. So again, just like what we did with example number 4. So insert original equation, which is integral of sine ln of x dx is equal to, copy this, x sine of ln of x minus x cosine ln x minus integral of sine ln x dx. Then we have here 1. Then if we transpose this to the left side, it will become positive 1. So what happens? We have here 2. Integral of sine ln x dx is equal to x sine of ln of x minus x cosine ln of x. Then we will multiply both sides with 1/2, so that this will cancel. What's left is integral of sine ln of x dx is equal to 1/2 x sine ln of x minus 1/2 x cosine ln of x. Okay, so I will accept this already as the answer. Oh, and don't forget plus c. If there is no plus c in the final answer, then that is wrong. You need to include plus c always. Okay, so that is for example number 5. So screenshot again the solution. Okay, so that ends the lecture video for integration by part.